Yeah. So now I would like to formally request and introduce our today's keynote speaker, Professor Balasubramanian from Singapore. Professor Rajasekhar Balasubramanian is a Provost Chair Professor and Group Head, Hydraulics, Hydrology, and Climate Resilience in the Department of Civil and Environmental Engineering at the College of Design and Engineering, National University of Singapore. He also holds the title of Keppel Professor in Sustainability Solutions. His research spans air quality, climate change, environmental sustainability, and public health. He is the recipient of numerous teaching and prestigious research awards and is recognized among the top 100 scientists in Asia. Professor Bala is an elected fellow to the UK Royal Society of Chemistry (RHC), the American Association for the Advancement of Science (AAAS), the American Geophysical Union (AGU), the Asian Aerosol Research Assembly (AARA), and the World Academy of Sciences (TWAS). He serves as editor for Aerosol and Air Quality Research and Environmental Chemistry book series published under RSC. He sits on the editorial boards of leading international journals, including Atmosphere and Scientific Reports. Today, we will be listening to him on a very interesting topic titled Healthy Living in Healthy Cities. Now, I will officially request Professor Rajasekhar Balasubramaniam, sir, to please deliver his keynote address. Over to you, sir.
All right, thank you very much for the introduction. I hope you are able to hear me. Am I audible?
Yes, sir.
Wonderful. So this is a students-led conference. Is that correct?
Yes, sir.
Wonderful. Yeah, I'm glad that you students came together to organize this important conference. So this provides a platform for us to interact with each other and learn from each other. Incidentally, I happen to be in India today. We are in the same time zone, but of course, I'm in a different city. But I'm really glad that I have this opportunity to connect with all of you. So here we go. I hope you are able to view my slides.
Yes, sir. They're visible.
Let me try to go to the presentation mode. Here I am. All right. So basically, I'm going to be talking to you about healthy cities and healthy living, more like the connection between the two. So unless the cities that we live in are healthy, we cannot remain healthy because our health is primarily dependent on what kind of pollutants we are exposed to in terms of air quality, what kind of water we drink, and what kind of food we eat on a day-to-day basis. So there are different pathways through which the pollutants in the environment enter the human body and cause a variety of health effects. But for this talk, I'm going to be primarily talking about the improvement of air quality and then what difference it's going to make to us in the long term. So as was introduced before by one of your students, so I have a whole bunch of interest. So it basically cuts across environmental sustainability, climate change, air quality, indoor, outdoor, and air pollution control as well. So basically, I don't just study problems, but also try to find potential solutions to problems so the solutions can be implemented in the most cost-effective way. So that is a central focus of my research. And these are my students with whom I have been collaborating for a number of years. So although I have a lot of research interest myself, unless I have talented students or researchers, I will not be able to deliver, what I would like to. So basically, I strongly believe in collaborative research. I'm very fortunate that I have talented PhD students and postdoctoral fellows. And then, they come forward to work with me. And so they enhance my experience and the ability to provide cost-effective solutions to problems of different types, including air quality. So one of the major challenges that we have globally is the population growth. And if you really track the human population over the last few decades, you will realize that the increase in human population is pretty much exponential. And so right now we have about 8 billion people and living in different parts of the world. So our planet has not been designed to support the life of 8 billion people. So when I say 8 billion people, basically I'm referring to the people who kind of are greedy, which means that, we end up consuming a lot more resources than we should be. And as a result of unsustainable consumption of limited resources, we end up degrading the kind of quality of the environment we live in, and hence our health is affected accordingly. But on the one hand, we have a lot of cities that attract a human population to contribute to economic growth, which is good. On the other hand, when you have too many people living in cities, it will also lead to pollution of different types in our environment. So the key question is, how do you make cities more sustainable, more livable, and more climate resilient? And these are the three important goals we have at the moment. And so I'll be talking about these goals, in a very broad perspective. So one of the issues of concern now globally is the decrease in air quality. In fact, it has been very well documented by the World Health Organization that about 90% of the cities worldwide do not meet the air quality standards or guidelines as stipulated by the World Health Organization. And so basically all of our, health is at elevated risk because of continued exposure to air pollutants at different times. In particular, we are talking about particulate matter, or PM, as simply referred to. And particulate matter, comes in different sizes. And so, for example, we get PM10. PM10 refers to airborne particles with a diameter greater than 10 micrometers. And we also have PM 2.5. So these are smaller particles with a diameter close to 2.5 micrometers or less. And we also have another type called ultra fine particles. So these are particles that have diameter less than 100 nanometers. So we have three different types of particles floating around in the air to which we are constantly exposed to. So that's one of the problems we have. On top of it, we also have something called urban heat island effects. So what does that mean? So if we track the temperature of air in cities and compare it with the temperature of air in the surroundings, especially during the night time, you will realize that in general, the temperature of air is higher in cities during the nighttime as compared to what we have in the surroundings. And the question is why? And the reason is that during the daytime, of course, the surface of our planet would absorb the solar radiation, and that in return, during the nighttime, the radiation absorbed or the heat absorbed by the surface will be emitted into the air. But we have in cities nothing but a concrete jungle. So we have a lot of buildings, and as you could see over here, when you got too many buildings in a limited space, then the cities tend to be warmer during the nighttime, which is what we refer to as the urban heat island effects. So what's the implication of urban heat island effects? So one of the effects is that there's a change in our microclimate. So what I mean to say here is that if you go to some cities, in some parts of the cities, it could be warmer than other places, or you could also have rainfall, more abundant rainfall in certain parts of the cities compared to other parts. So one would start wondering, as to why we have so much of diversity in terms of weather conditions within the same city. And one of the main reasons is the so-called occurrence of urban heat island effects. So on top of it, we also have a lot of energy consumption. Just imagine we got so many buildings over here, and we need, illumination, we need lighting, for the indoor environment, and also on streets. And so if you just track the amount of energy consumed in cities, it's pretty high. Then if we trace it back to where the energy is coming from, you would realize that, as of now, in most of the cities, energy is derived from fossil fuels of different types. It could be coal, it could be oil, or it could be natural gas. And natural gas is the cleanest fossil fuel we could think of. On the other hand, we are also putting a lot of emphasis on renewable energy, including solar energy, wind energy, geothermal energy, bioenergy. I can go on and on. But if you look at the share of renewable energy as compared to fossil fuels, it's not pretty significant. So globally, the contribution of renewable energy to the total amount of energy generated is about 20%, so not very high. Still, about 80% of our energy is primarily derived from the continued use of fossil fuels. So what? And basically, we use a lot of fossil fuels. They all contain carbon in them. As a result of increased energy consumption, we end up emitting a lot of carbon dioxide together with other greenhouse gases, all of which will contribute to global climate change. So there's another problem we have in cities because of unsustainable energy consumption. So let me see if I could go to the top. I could hide the. Great. Yeah. So as a result of these reasons, our health is constantly declining over time within cities. Okay. And what I propose is to make use of nature-based solutions. And so, in a way, we want to sort of regenerate greenery that we used to have in the past prior to urbanization. And the reason why I'm so keen on utilizing nature-based solutions is because we are not consuming any energy. So basically, we take advantage of greenery or vegetation we have in different parts of the cities, in and around buildings. And the presence of vegetation in cities could make a huge difference in terms of providing co-benefits, some of which are listed over here. And I'm sure most of you would know what I'm talking about. But in any case, I would expand it further. And when you have a lot of greenery and it provides habitats for wildlife, more importantly, it tends to improve our biodiversity. We have more biologically diverse species within cities, and more and you'll see why and how later. And it could also lead to reduction in noise pollution and urban heat island effects, which I mentioned earlier. And it also reduces mortality and morbidity. And again, if you estimate the number of people that die prematurely in cities around the world, and you would realize that the 0.5 million people every year globally because of exposure to air pollution, both indoors and outdoors. Primarily, this problem is happening in developing countries, more than developed in developed countries. So we have premature deaths happening in developing countries in particular because of exposure to air pollution. And morbidity. And the morbidity here would refer to the greenery we have would also improve human mental well-being. And just imagine if you go to a park, if you go to highly vegetated area, your mood tends to be more elevated than just walking around in cities. So as a result, our cognitive power, cognitive ability in terms of critical thinking ability would also enhance, would also increase as a result of greenery we have. And then, as I mentioned before, it will lead to energy savings. And when you have greenery in cities, it also pulls a lot of people, tourists in particular. So you can see a whole bunch of co-benefits that could be derived from urban greenery, environmental, economic, and health benefits. But in this instance, I'll be mainly talking about health benefits as a result of expanded greenery to be in line with the theme of the conference that you have organized. So one of the questions we have been asking in our research is whether or not we should have vegetation barriers on the side of the road. If you look over here, so this is where we have, the roads carrying traffic, vehicular traffic of different types. So usually we have a combination of buses, trucks, and you have cars, private cars, taxis, and motorcycles. And so the number of such vehicles could vary from cities, from one city to another city. In our case, we have about 1 million vehicles in particular in Singapore. And so we have about 6 million people living. For a population of 6 million people, we have about 1 million vehicles on road. So we made a lot of drastic changes to improve air quality. And one of the policies that we are going to be implementing soon is to replace all fossil fuel cars by electric cars. Not 100%, but most of the fossil fuel cars will be replaced by EVs. At the same time, we are also promoting public transport. So we encourage people to go, cycling or walking or use the public transport like buses or trains and so on. So that in a way would lead to health benefits. And so on top of that, we would still have some buses or trucks on road after 2040. By 2040, we would phase out all fossil. So basically, I was talking about the importance of having expanded greenery in cities. The question then is like what kind of greenery that we should install on the side of roads in order to protect the health of people who believe in cycling or walking on the side of the road. And so that's a central question that we have addressed in our research. So let me see if I could go to the presentation mode. Here I am. So, and we could have trees, we could have hedges, and we could have other types of vegetation on the road. So we wanted to find out and through our research as to what kind of vegetation barriers that we should install on the side of roads so that people are not exposed to air pollution coming from the local traffic. And then the way the air quality could be influenced in a positive way is in a positive manner is through impaction or sedimentation or diffusion. So I don't want to go into the physics behind it, but based on various mechanisms involved, and the exposure to particulate matter could be significantly reduced as long as you have the right type of vegetation barriers being installed on the road. And the question is, what kind of vegetation barriers and why? And so this is a key objective of our research. And so we basically monitored the kind of traffic we have on roads in Singapore. And we physically counted the number of buses, trucks, and motorcycles and cars we have at any point in time on a particular road. And then we also went to two different types of roads and people with roads with the vegetation barriers and roads with no vegetation barriers. And we want to compare and contrast of the kind of air pollution that people are exposed to on the pavement of roads in the presence of vegetation barriers versus in the absence of vegetation barriers. So that's a central objective of our research. And we got selected 16 different sites within Singapore. And then we deployed a number of in situ instruments that have the capability of tracking the exposure people of on the road to air pollution, primarily derived from the local traffic. It's a very comprehensive research. And you could see in the schematic over here, and we looked at the exposure to air pollution where we have wide space with no vegetation at all. And then we compared and that exposure to other areas where you have some kind of vegetation barrier, and then compare and contrast to see how much of a difference you have in terms of exposure to traffic derived air pollution with particular reference to particulate matter, which are proven to be harmful to humans. And you could see here the instrument that we get deployed, and these are battery operated devices, and they are portable, and yet they are calibrated against the bulk monitors we have in the lab. So in other words, the devices we get deployed are proven to be reliable in terms of accurately measuring the concentration of particulate matter of different types derived from the local traffic. And then these are the number of vehicles we have in different parts of Singapore. On certain occasions, you could have about 16,000 vehicles per hour. In other locations, you could have a few hundred vehicles on road. So again, the question here is what contributes to such a large density of vehicles on road? And that would depend on whether you do the measurements during peak hours or non-peak hours. So during peak hours, like 7 o'clock in the morning until 9 o'clock, people go commuting to work, and the evening hours, like again 5 to 7 p.m., they return to their homes after work. Again, there's a peak hour traffic. So during peak hours, in certain locations, you would expect to see a lot more vehicles as compared to other areas or even the absence of peak hour traffic. So, and then we also looked at the composition of vehicles over here. And as you could see, 76% are nothing but cars. Then we got buses contributing to about 6%, motorcycles 7%, and trucks will be 11%. So the key message here is if we can give up driving, if we encourage people to use the public transport for commuting, we can basically solve a major problem that we have. And so how do we convince people to stop driving? That's an entirely different issue, right? And so we have to take help from behavioral scientists and rather than actual scientists. And so this is something we are actually working on at the moment. So then we basically looked at the reduction in exposure to soot particles. So soot particles are coming mainly from diesel-driven vehicles like taxis, trucks, and buses. Now you could see here in places where you have hedges, so meaning you have tall vegetation barriers with multiple layers. We have one or two, three layers, and tall vegetation barriers. Such vegetation barriers are very effective in reducing the concentration of soot particles emitted by buses and trucks that are primarily diesel driven. But if we go to other locations where we have other types of greenery, and these types of greenery are less effective as compared to the hedges. So this is one of the most important discoveries that we have made in terms of identifying the type of vegetation barriers that we should install on the roadside. So this is something I would like to expand further a little later. Okay, so then we also looked at the exposure to particulate matter. So now if you look at this image over here, these are the hedges I'm talking about. And you have three different layers over here, 1, 2, and 3. On back side, you have trees. So when you have this such thick vegetation barriers, then of course the particulate matter that are emitted by traffic cannot penetrate across the vegetation barriers. In other words, the particles are efficiently captured by the vegetation we have over here, and hence it leads to improvement in air quality. On the other hand, if you have trees, of course, it will look beautiful, but you got a lot of wide space. So the vegetation density is much smaller as compared to the one you have on top. So such vegetation barriers are less effective in capturing particles, and hence the improvement in air quality is not so significant when you have this kind of vegetation barriers over here. So now moving on, we also looked at the exposure to ultra fine particles, and these are the particles that are extremely small in size, and the size could be less than 100 nanometers, and these particles are easily inhalable by humans, and the bigger particles are retained in our nose or throat. The normal mechanism is to kind of cough out or sneeze out, and and the particles will be excreted. On the other hand, the smaller particles will continue to travel all the way into the interior parts of the lungs, in particular the alveoli region, where the particles could be deposited in the lungs, and the particles then could be transferred into the bloodstream. And the particles are not just inert matter, they also contain in them a lot of trace elements, which is something you are talking about in the conference. And the trace elements could be toxic, like copper, zinc, and so on, and iron. These are the toxic metals that are emitted by the local traffic contained in particles, especially ultrafine particles. And then such heavy metals can be transferred into the bloodstream, affecting our health in the short term or in the long term. So the bottom line, again, when you have hedges with the different configurations, such vegetation barriers are also effective in reducing our exposure to ultrafine particles apart from black carbon. However, the effectiveness of other vegetation barriers is not so significant as compared to hedges. Okay, and then we also looked at PM 2.5 concentration, and these are the particles that are regulated at the moment. And according to the regulation, the PM 2.5 concentration should not exceed 10 micrograms per cubic meter, especially in Singapore. And then when you have vegetation barriers, we are able to significantly reduce the concentration of small particles like PM 2.5 on the roadside, and hence people who go walking or cycling would breathe cleaner air on behind the vegetation barriers, as we could see over here. So then we also compared the kind of particles that we have, and the size and shape would differ from place to place. Then basically we looked at the morphology of particles that are captured on the leaf of different the vegetation barriers. So that provides a conclusive proof that vegetation barriers do collect and retain particles of different sizes onto the surface, as you could see over here. Then we also looked at the particle size distribution, and you could see here particles comes in different sizes, and most of which are captured by vegetation barriers, and hence it would lead to significant improvement in air quality. Okay, so what kind of trace elements we have? So I have already highlighted. We have aluminium and silicon. These are basically coming from the dust particles we have on the road or from soil. On the other hand, you have iron and magnesium would come from fuels that we used in the local automobiles, and zinc would come primarily from tires. And if you look at car tires, and zinc is used as an additive, and that will be emitted with the time, and copper comes from brake wood. So what you can conclude here is that we have a lot of toxic metals being emitted for the local traffic due to both exhaust and non-exhaust emissions. So the bottom line is that although we could replace fossil fuel cars by electric cars, the misconception is that there will be significant improvement in air quality, which is partly true.